Okay, so this is the last part of carbohydrates we're going to look at. In this part of the lecture, we're going to look at artificial sweeteners, and we're going to go through some of those. We'll look at fiber as well and sugar alcohols. Now, when we start this, understand when we talk about artificial sweeteners, I could go through literally 30, 40 different sweeteners we could look at. That would take forever. So I'm just actually going to go through four. I'm not saying these are the four most important. I'm not saying these are the four best ones for you. They are definitely four of the most common. There are some, I'm not going to get into, stevia being one of them, although I probably should. It's newer, it was really just finally approved in 2011, but it is definitely increasing in its use, particularly in other countries like Japan, but here in the US as well. Some other ones like Truvia, I'll kind of get into that a little bit with sugar alcohols. So just understand, there's a lot of sweeteners out there we're not going to go through, but just kind of these four. This is also not in your book. So be aware as we go through this. This is kind of extra. Your book doesn't go really in depth in this kind of stuff. Okay, so when we talk about sweeteners, a couple things to understand is that we are talking about, one, things that are FDA approved. Now, whether that means they're really healthy for you or not necessarily, they're all approved by the FDA, and they all generally are low or no calorie sweeteners. And that's a key part to understand because, with the growth of high fructose corn syrup and want to sweeten foods, then you throw on top of that the move towards low calorie, no calorie, soft drinks, foods, snacks, things like that. Well, when you remove those calories, you still need something to sweeten the food. And so this has really caused artificial sweeteners to be incredibly, incredibly common. And in fact, my guess is even as we speak, you might be watching this and snacking on something that probably has an artificial sweetener. So they are that popular. So all of these I'm going to go through generally are considered low calorie, no calorie. I'll try to explain that a little bit better how that occurs. All right, so the first one I'm going to talk about is sucralose. Sucralose, also known as Splenda, though they're not exactly the same. Splenda is a derivative of sucralose. Sucralose basically comes from sucrose. You can look at some of the chemistry here as far as the hydroxyl groups. A couple key things to know about sucralose is, one, it actually passes through the GI tract unabsorbed. And so if you remember when we talked about absorption of monosaccharides and we have our GLUT transporters and our Siglet transporters, sucralose does not go through that digestion, doesn't get absorbed. And so not surprisingly, if that isn't absorbed, there's no caloric intake with those. So that's one way sucralose is used a lot. Sucralose is fairly new. It came on the market kind of in the mid 70s or so, something like that. And one of the things that it became very important, and the reason it became very popular and still is that it can be baked and be cooked at higher temperatures. It still maintains its sweetness. So because of that, you see it used a lot in sweeteners, dairy products, things like that, that when heated can maintain their integrity and their sweetness. Sucralose is also very sweet. Not surprisingly, it's actually so sweet, it's not uncommon to see it combined with another sweetener. In fact, truthfully, that happens with a lot of our sweeteners. It's not uncommon to see sucralose combined with ACE K, which we'll talk about in a few minutes, sometimes even combined with high fructose corn syrup. So not surprising to see combinations of a lot of these. Nowadays, very popular, and Splenda especially has become very common in mixtures and a lot of different sweetened foods, from soft drinks to mixes of smoothie mixes, things like that, particularly low-calorie smoothie mixes, often combined with maltodextrin to make a more long-standing sweeter sugar. And the research says that there probably is very little concern with this over long term. And so because of that, it's become a very, very common sweetener that we can look at. So sucralose, Splenda is our first sweetener we'll look at. The second one is called aspartame, or at least what we call the grown-up NutraSweet. Aspartame is really unique. It is actually metabolized by the body, and technically it's really actually not even a sugar. It has a methyl group, amino acids, and that's really where some of the caloric value comes from. But because of that, because of its chemical structure, though it has some caloric value, truth is it's barely negligible. So we generally say it's no calorie, though it's technically not true. Now, aspartame, when I was growing up, NutraSweet was very popular in the 80s. Equal is one of the things we call it. You would often put it in different drinks and coffee and things like that. However, it also became very controversial in the 80s and the 90s. A lot of concern about potentially maybe related to cancer and rats and things like that. There was times it was investigated by the FDA and then not. And so here in 2017, we generally consider it healthy. One unique group with this, though, are those who have what's called phenylketonuria, or PKU for short, which is an inability to metabolize phenylalanine, which is a key part of this. Phenylalanine is an amino acid. Individuals who have this disorder need to not take NutraSweet. This is high in phenylalanine, and they're unable to metabolize that and can cause real problems. It can be lethal, to be honest. So NutraSweet, aspartame, very common. Nowadays, I'll be honest, you generally don't see this alone. You generally see this added with another sweetener or something else, just because in and of itself, just not very common to see. But Equal is also one of those places we'll see it by itself. So aspartame or NutraSweet. Another one, and this one's probably the oldest one around, called Saccharin. In fact, Saccharin, unlike these others, which were discovered in the 60s and 70s, Saccharin was actually discovered in the 1830s, 1840s. Actually, totally by accident. The researcher, in case you care, who discovered this, they're actually doing research on coal tar, with roads and stuff. And so he, by accident, touched one of the ingredients he was working with, thought it tasted sweet, and boom, we had saccharin. Now that's really simplifying kind of what happened as far as saccharin goes. But basically, saccharin has been around for more than a century as a sweetener, one of the first sweeteners. Doesn't accumulate in the body. We rapidly get rid of it, and it is crazy sweet. In fact, so much so, it's long been known to have quite a bitter aftertaste, which is why nowadays you almost never see the sweetener by itself. You usually see it combined with a sweetener to deal with that aftertaste. And not as popular today, but you do still see it in soft drinks, things like that. Really inexpensive to make, also, by the way. So not as common today, but we still do see it. Not uncommon to see it as a sweet and low on a desktop somewhere in an old coffee shop or diner or something like that. Saccharin is still fairly widely available. This last one we're going to look at is called Acyl or Ace K is often what it's called. You may know the commercials, Ricola, terrible voice. Ace K has become popular, especially in the 80s and the 90s. I think it was discovered in 88. That's when it got FDA approval in 88. And what makes this a little bit unique is not only does it act as a sweetener, not only is it sweeter than sugar, it also has a unique kind of taste to it, so that it's often found in things that need a what's the word I'm looking for? A minty kind of sharp flavor. So not surprisingly, we see this in breath mints, cough drops. We often see it combined in these things with sugar alcohol, which we'll talk about in a second. There is some concern in taking this with prenatal development, although that research is not necessarily succinct. But we do find this, again, in a lot of different sweetened foods. We also find it in baking goods as well, cookies, things like that. It's not shocking to find Ace K. So again, this is some of the sweeteners we look at, not all of them. There's still a lot of others we can look at. Another group here, though, that I don't want to ignore are sugar alcohols. And sugar alcohols are unique because they are carbohydrates. They are natural carbohydrates, but they are absorbed differently than other mono and disaccharides are. And so some of these, you don't have to memorize these, but glycerol, sorbitol, xylitol is a common one, erythritol, which is a very common one now. It's not even on this list. A lot of these we throw in the category of what's called low impact carbohydrates. Because of their slow absorption, they have very little caloric value. Some of them are used to act as sweeteners. Some are used to cover the aftertaste of other sweeteners, like saccharin. Other than these have unique tastes. Sorbitol, for example, has a bit of more of a minty, like Ace K flavor. Not surprisingly, you find it in mints, chewing gums, especially zero-calorie chewing gums. Other ones like mannitol, very common in baked goods, diabetic foods, because it has a really low glycemic value. It's almost zero. Other ones like erythritol is very common in Truvia. It's an agreement in Truvia, which is very common today. So all these are different sugar alcohols we'll see often in baking. Mannitol, glycerol especially we'll see in icings of cakes, things like that. In themselves, not harmful. These can cause some digestive issues in some people, especially mannitol and I think sorbitol, if I remember correctly. But otherwise, when it comes to sweeteners, fairly healthy. So these are some of the sweeteners and alcohols I want to look at. Last and certainly not least, I want to talk about fibers. Because fiber tends to be an ingredient of our diet. We often say we want to have a diet high in fiber. What does that mean? Well, dietary fibers, as we talked about with polysaccharides, they're carbohydrates. Many of these are plant foods, but we don't easily absorb these. And so because of that, it makes them a unique carbohydrate. There's soluble fiber and insoluble fiber. We'll talk about that in a second. And typically, these are going to be your plant-based sources, legumes, vegetables, fruits, brands, grains, things like that. Now, why is fiber important? Why having this in your diet? Well, soluble fiber, soluble meaning dissolving in water, is key because it binds with fatty acids. And by doing that, it allows their slow absorption of fats, which is key to caloric intake. Also allows absorption itself to be slowed down. And there's substantial research that says soluble fiber improves HDL, decreases LDL cholesterol, which are really, really huge key impact factors on health. So soluble fiber, insoluble fiber doesn't dissolve in water, but we also know it is a key ingredient in reducing ulcers, improving digestive tract health, even removing some waste from the colon. There's research that says it has a role in preventing colon cancer by making some alterations in pH. And so both insoluble and soluble fiber is key to have in our diet. And so when we talk about high fiber foods, generally these are more plant-based grains, vegetables, things like that, that aid not only in that a lot of these are typically healthier carbohydrates, lower glycemic index value carbohydrates, more complex carbohydrates. They are also generally going to slow digestion, slow absorption, improve the digestive tract, and even assist in absorption of fatty acids and other vitamins and minerals. We'll get to that in a few weeks. So key aspect here, soluble and insoluble fiber, key parts of the diet. So again, this is in your book. The sweeteners were not in your book. Sugar alcohols, I believe, is in your book, so you can take a look at that. But yeah, this is it as far as carbohydrates. The next chapter we'll go into, I believe, is chapter 5. We'll cover that in the next lecture.